9702, May June 2019, paper 1, variant 2, and the question number is 19 regarding work power energy efficiency. A train on a mountain railway is carrying 200 people of average mass of 70 kg up a slope at an angle of 30 degree to the horizontal and at a speed of 6 meter per second. So we need to understand here the speed is constant, means there is no acceleration, means the force are balanced, right? Number one. But the force is there, but it's not actually changing anything, right? The only force which is available here is actually the weight, the component of the weight. Okay? So the train itself has a mass of 880,000 kilogram. So here we also need to think that the mass of the train is 80,000 and there are 200 people each having 70. So we need to add all the masses, which is approximately equals to 80,000 plus 200 times 70, which is 94,000 kilogram. Okay. So we have calculated the mass as well. Now, the power, the percentage of the power from the engine which is used to raise the passenger and the train is 40%. Only the engine, whatever the engine is supplying energy and producing power, only 40% is used. So, the rest maybe the power loss. What is the power of the engine? Okay, so we have I guess we could see we can utilize the formula of efficiency, which is efficiency in percent is equals to P naught over Pi, useful power output divided by power input times 100. We will get efficiency in percent. So by this we will say that power into 40% of the power input is actually P naught. So 40% of power input is actually P naught. So here we have. Now another thing. First we need to calculate what is actually the power output, right? So we have the power output. How can we do that? We have the efficiency, which is power output. How can we calculate? We can calculate is the power is actually the work done over time. So work done is F into S, which is distance over time. So its distance over time is speed because the speed is constant. So the another formula of the power is force times speed. Force times speed. So the 40% of the input power is using and it equals to the power out useful power output. So we can calculate the power output as force. Now force here we could say the inclined plane having an angle of 30. So the weight of the whole engine plus the passenger is mg sine theta because phi component of the weight is using over here. So this is the force mg sine theta. So m we have already calculated 94,000 kilogram and G is 9.8 and sine theta is sine 30 degree it is given. So the total force and actually the vertical component of the weight is 460,600 in times speed we will get the power output and the power output times 100 divided by 40 will be equal to the power input, which that means the power generated by the engine. So it will be 690,960,000. So in the megawatt, it is 6.9 into 10 power 6 MW. So option C is the right answer.